Okay, so now we're going to factor trinomials. And as we talked about things early on, um, this is a result of FOIL. Okay, so when we FOIL something, we distribute two binomials and we get a quadratic. Well, now we're taking that quadratic and we're factoring it back out into something that looks like two binomials. So we're going to start with the quadratic, and our quadratics have a generic equation. Our generic equation here is an ax squared plus bx plus c, where a, b, and c are all numbers, okay? And if we want this thing to come back out and look like two binomials, the way we've got to do this is first times last, so ac, two factors that we don't know yet, we've got to find. So this is kind of a search for a missing puzzle here, that add up to be my middle or my b term. Okay, so this is the equation, the generic equation that we're going to use today. And it's the generic equation we're going to use in our next lesson as well. Today, every time we do this, a will be 1. Okay, when we do it again, this a value may be more than 1. I'm going to explain it just as if a was a value every time. All right, and then as we go on to progressive lessons, it'll change some. All right, so let's get an example here. Got an example. Let's go x squared plus 6x minus 27. Okay, as you recall from previous lessons, we always look first to find a greatest common factor. Well, I can't pull an x out of everything, and there's not a number in anything. So we're going to have to factor this a little bit different. Just like our previous slide, we're going to take our first, and our first, and when we don't have a number here, this guy can always be 1. So 1 times negative 27 gives me negative 27. And yes, the signs are important. Two factors of negative 27 that add to get 6. Now sometimes these will be a little harder than this. I picked something that, relatively speaking, we can kind of ease into. I've got two factors of 27 that I can either add together or subtract and get 6. In this case, a 3 and a 9. 3 times 9 gives me 27. Well, positive times a positive doesn't get me a negative, so one of them has to be negative. Which one has to be negative? What's the one that makes us a positive 6 when we go across here? So it is a negative 3 and a positive 9. So negative 3 plus 9, difference of 6, sign of the largest positive, gives me positive 6. 3 times 9 is 27, and a negative times a positive is a negative. So this guy works. If this guy works, it factors. All right, and because of this, we can now come down here and say, okay, this looks like FOIL. So my FOIL, I can just script that out. Because this is 1, I can go right to this step where I get x squared. Well, this is the result of my first terms. So this is an x, and that's an x, gets me x squared. Then it's just a plug in. So I get minus 3 and plus 9. Now, here again, if I wanted to check that, my first, as I said earlier, gives me x squared. My first outsides gets me plus 9x. My inside is minus 3x. And my last gets me negative 27. And as you can see, this guy together gives me a 6x. So drop everything down. I've combined like terms, and I get right back where I started. And this is always a good idea to do, is check your work when you're done. Let's do one that's a little bit more than that, not a lot. Okay, let me back to black over here if I can. All right, so let's try this problem out. Let's go x squared plus 5xa plus 4a squared. And what you're going to see here is we've got multiple terms. Now the greatest common factor, we don't have anything of all three of those terms, but we have an x squared here, an x and an a, and over here an a squared. when you do these problems like this, we have to have some kind of an order. We talked about being in order as much as we could before. This guy actually is in order. We don't have to conform, to rearrange or conform this to a different way, because my x squared, if I go exponentially, this is 2, that's 1, and there's none there, or 0, which is anything raised to 0 power is 1. So my x's are in exponential decreasing order, where my a's are actually in exponential increasing order, which is perfect for this problem. So yes, you can rearrange this, but this problem doesn't need it. All right, so we do first times last, so 1, remember this 1, times 4 is 4. 2 factors that had to get 5. Notice I'm not worried about the letters. The letters will play into themselves. Okay, so 2 factors of 4 to get me 5. Well, that's just simply 1 and 4. And they both have to be positive to get this positive here and to get that positive there. So this pyramid scheme is what I call this. It works, so therefore it factors. So I can go right to this 2 binomial product. And remember, I can get an x squared here. But now I have to remember that I get an a squared on the back side. So I get an a there. And now the numbers just drop. So this becomes plus 1, or just simply plus a. And this guy becomes plus, and I left it a little tight, and I get a plus 4a. So I get an x plus a and an x plus 4a. Here again, if I check that real quick, I get x squared. I get plus 4ax plus ax, which is plus 5ax, and my last gets me plus 4a squared. So I did this step in my head. I kind of talked it through, but those are things I can do in my head. And the more familiar you get, the more apt you're going to be in doing that, the more able you are. Okay, let's try one more that looks just a little bit different. Okay, and it goes back to something that I've mentioned. Didn't put a lot of stake at it right at this point in time, but here it becomes a little bit more valuable. Okay, so cubed plus 30x squared. Now, as you can see, first times last year is going to be 150. There are a lot of factors to 150, which makes this guy quite problematic. But if you remember my greatest common factor, I can get a 5 out of every single one of these. We'll get that 5 out. So anything else I can get? Well, I can get an x out. How many is the most x's I can get squared? So now let's rewrite this other factor. So I get an x squared. I get minus 7x, and I get plus 6, and I'm done. Now, there will be times where this trinomial won't factor. Please don't put does not factor, or your book, or most books might put that as prime. We've already factored something out. Okay, my greatest common factor tells me this factored already, but I have to see again to see if this trinomial factors. So here again, I'm going to come off to the side this time. 1 times 6 is 6. 2 factors that add to get 7. Well, those are 6 and 1. So this guy here, this trinomial, goes to x on the front sides, plus 6 and plus 1. Now please don't forget, I got to bring this guy down too. That way when I multiply everything back, that's a 2, I get back to my original problem. All right, so as you can see, that greatest common factor comes into effect here, as well as it did in the in one of the previous sections that I assigned in the videos.